All right, hello and welcome to the 4-3 reteaching instructional video. This is for triangle congruence by ASA and AAS. So two more ways to prove triangles congruent. Let's give it a look. This says, can the ASA postulate or the AAS theorem be applied directly to prove these triangles congruent? So looking at this first figure here, we see two triangles that are attached by the reflexive side. Okay, so we know that that reflexive side is shown congruent. So we can go ahead and make a mark to that effect here. We go ahead and add some color to this one. Okay. So since we know that something always equals itself, we can say that side ED is congruent to side ED. And it says that here. It also notes that the angle D's are congruent, the right angles, and it also notes that angles R and A are shown to be congruent. So we do have one pair of angles right here. This is one pair of angles. We have a second pair of angles, so this is an angle, this is an angle, and then we have this pair of sides. I know it only looks like one side, but there's two triangles here, so if you separated them, you have AAS. You have an AAS situation here, angle, angle, side. So you can say that triangle RDE is congruent to triangle ADE by the AAS theorem. Let's look at the second one. On the second one, I'm noticing that I have two triangles here that are stuck together at a vertex. I already have a pair of sides here, okay? So I have a pair of sides here, already marked congruent. And I have another pair of sides here. I'm sorry, angles. I have another pair of angles here, okay? Now, one thing that I do need to note here is that I also have a pair of vertical angles. This angle here, angle CHE, and this angle here, angle FHB. Those are vertical angles, so we know that they are congruent, and they've noted that here also. It says it gives you that CH is congruent to FH, and it gives you that angle F is congruent to angle C. Because angles CHE and angle FHB are vertical angles, we know that they are always congruent. So because of that, we do have, and I'm going to go ahead and show here that this is another pair of angles. So here you can see we have an ASA, angle, side, angle situation. Also want you to notice that this side that is marked congruent is between the angles. It is the included side. The included side. Whereas notice over here, the side that is marked on this first example is not between the angles. So this is not an included side, which is why you have to use AAS instead of ASA. I hope that makes sense. Let's type some notes to that effect. Notice on example A, side ED is not an or the included side because it isn't between the congruent angles. So we have to use AAS where the S is not between the A's. Okay? Whereas on this side, I want you to notice, please, or notice on example B, little b, that sides CH and FH are the included sides because they are between the congruent angles. So we can use angle side angle where the S is between the A's. I hope that makes sense or translates in this video form. So looking at a few exercises here, we are just going to do 1 through 9 here because again we are not proof centric right now, so we are not going to worry about problems 10 or these are all proofs on the second page, so we're not doing that. No, we're not. We are worried about the concepts. We're going to make sure we get it and not focus on a proof. I don't even think that's in the state objectives anymore. As it shouldn't be. Okay, so we just have 9 little exercises here. This is to copy the figure at the right. which we don't need to do because it's right there. Mark the figure with the angle congruence and side congruence symbols that you would need to prove the triangle's congruent by the ASA postulate, okay? Well, first of all, we can see we have parallel lines here. Because we have parallel lines, we know that we have alternate interior angles congruent. Alternate interior angles congruent there, okay? And we know that we have a reflexive side congruent here. I'm going to use color here to describe these things, okay? So I know that I shown in red here, alternate interior angles congruent, because lines are parallel. Okay? And I also note, I'm going to change color on this one. Also note that I have a shared side. These two triangles share this side, so I have a reflexive side here. So the blue hash that I'm making here is for a reflexive side. Reflexive side is a shared side, or reflexive piece is a shared piece. Congruent. Because something's always equal to itself. Hope that makes sense. Okay, so they want to know, mark the figure with the angle congruence and side congruent symbols that you would need to use ASA. Okay, so if I'm going to use ASA, let me go with green here. The additional information that I would need, let's find out what additional information we would need, okay? So I have angle and a side. In order for me to use ASA, the side would have to be the included side. So if this is going to be the included side, then I would need to be able to mark the angles that make that side the included side, okay? So I would need to be able to mark the angles that make that side the included side. We would need to be able to mark the angles congruent that would make it the included side. That would create an included side. Since I'm running out of room. Okay. Sorry, there's not more room on here. Okay, number 2 is the second thing. Mark the figure with the angle congruence and side congruence that you would need to use AAS. So this time we do not want the side to be the included side. But the first thing that we need to note here, first thing we need to do is just separate these problems because there's so little room on this figure. Sorry about that. All right, so all of this was for number 1. Let's give number 2 a little bit of space. Darn little. Okay. All right, so we're going to get us a color here. Okay. So on number 2 here, we can see we have one pair of congruent angles already, and you can see that we have a pair of vertical angles. So we can definitely mark the vertical angles congruent. Okay. So those should be things that we are automatically noticing and automatically doing. We should be recognizing, oh, there's vertical angles there. I can definitely mark those congruent. Vertical angles always congruent. So in order to use AAS, we are going to need a side that is not an included side, okay? We're going to need a side that is not an included side, okay? So in order to find the side that's not the included side, we need to find the side that is the included side and pick a different one. This would be the included side because it's between those angles. This would be the included side because it is between those angles. So we could either choose this side or we could choose this side, okay? So that would be congruent to this one, or the hypotenuse would be, hypotenuses would be congruent. Either way, okay? So for this one, we would need the side, one of the sides, we would need one of the sides that is not the included side. in order to use AAS, because the S is not between the A's, so the side is not between the angles. Okay? So looking at 3, it says draw and mark 2 triangles that are congruent by either the ASA or the AAS theorem. Well, let's do both. Let's overachieve here. So let's go ahead and draw a couple of figures here. I'll tell you what, let's draw the triangles in black, and then we can mark them in the different colors. Okay? All right, so I'm going to draw a pair of triangles here. I'm going to draw a second pair of triangles over here. Okay. And then we'll put some markings on these things to show what they are. First of all, we're going to show the first one using the ASA postulate. Or I guess I could use AAS to make these things all together and nice here. Okay, so with the red, we are going to show using the AAS theorem, angle, angle, side. So we need a couple of pairs of angles. So we can say this angle, you go into this angle, and then we pick another one. We can go with this one. We can say that this angle must be congruent. Let's say this one. Okay. So in order to use AAS, we can pick anything but the side that's between them. Since the S is not between the A's, the side is not going to be between the angles. So we could say maybe this one. This will work. It's not between the angles. That's not between the angles. So this here is an example of the AAS theorem. Okay? All right. So let's grab another color here. Let's go blue. Okay? Let's see what we have over here. If we're going to use the ASA postulate, then we definitely do need 2 pairs of angles. So let's go with one angle here. Go into this angle here maybe. And then we'll go with the second angle. Congruent to a second angle over here. Okay? So in order to use ASA, where the S is in between the A's, the side would have to be marked that is between the angles. The side would have to be marked that is between the angles. So this then would be an example of the ASA postulate. All right, 6 more quick examples here. What additional information would you need to prove each pair of triangles congruent by the stated postulate or theorem? Okay, so, for 4, here we are looking to use ASA, okay? First of all, let's mark what we already know is true. We already know the reflexive sides. Any reflexive sides or vertical angles, go ahead and mark, and let's please make a note of that. You should always go ahead and mark congruent any reflexive sides, cannot spell today, and any vertical angle pairs. Okay? That's a gimme. That should be something that you should automatically be doing at this point, okay? So number 4, for example, here I have a reflexive side. I'm going to mark it. That's an automatic. I'm going to mark that, okay? On number 5, I have a reflexive side here. Remember, the reflexive side is the shared side, okay? On number 6, I have a pair of vertical angles. So I'm going to go ahead and mark that pair of vertical angles. Those should start jumping out at you. On 7, I have a reflexive side. So I'm going to go ahead and mark it. That means that it's a shared side between those 2 triangles. On 8, again, I have a reflexive side right there. And on 9, I have a reflexive side on there, okay? So those are the ones that you can automatically mark, okay? You might want to make a note, the reflexive side is the shared side, okay? So we are going to need to know, well, what else do we need? Okay, we already have the reflexive side. What additional information would you need? So for that, let's go to...
Good afternoon, teachers and students. At this time, all car drivers and car riders, you are dismissed, and at the bell, remaining students will be dismissed.
Okay, that means this video is taking me longer than I wanted it to. Sorry about that. Okay, all right, so this wants to know what additional information we would need to prove each pair of triangles congruent by the stated postulate or theorem. So for the ASA, for number 4, we have angle and we have side. We would need the other angle. I'm going to put a slash through that also. The other angle there, which would be the angle B's, okay? We need the angle B's there. So we would need to know, we would need angle ABD to be congruent to angle CBD. Okay? For 5, if we're going to use the AAS, or angle side theorem, we already have a side and an angle. We would need another angle that makes this side not the included side. So we could really pick either one here. Okay? We'll say K. Let's say JKM, and then let's say LKM. Okay? So for this one, we could actually use, well, let's say, we could pick the other pair too, we just can't pick them both. We could pick either pair of corresponding angles, but not both. Shown here is angle JKM congruent to angle LKM, and that would work. Okay? So looking at number 6, again, they want ASA. I have a side and I have an angle. I need another angle such that the side is the included side. So I would need angle X and angle V, because I want those angles to be the ones that's going to make that side between the angles. So since the side would have to be between the angles, since the side must be between the angles to use ASA, we would need to know that angle X is congruent to angle V. 3 more, we can do this. All right. For number 7, the AAS theorem, we have an angle and we have a side, so we don't need the D angles because that would make it to where that was the included side, and we can't have the included side here because, take it away. Okay, because that would be ASA and we need AAS, so we need the other angles here. We're going to need angle Y congruent to angle O. Okay, so for this one, we would need angle Y to be congruent to angle O in order to use AAS here, so that side DG is not the included side. Because if it was the included side, we would use ASA. And they want us to use AAS here. So hopefully that makes sense. Okay, on number 8 here, again, we want to use AAS. AAS, I have angle and I have a side. If I choose the angle T's, this is the same situation as number 7. Then that side would be the included side, and that's not what they want us to use. So we're going to have to choose angle P and angle A. So same situation here, excuse me. We would need angle P to be congruent to angle A, so that the side shown congruent is not the included side. Okay, so for number 9, last one, the ASA postulate. Here we have a side and we have an angle, but we want the side to be included this time. So we need to mark, or we would need to know that the angles that make that side the included angle were the ones that were going to be congruent, okay? For ASA, we do need the included side to be congruent. So we would need angle, let's say LYC, to be congruent to angle LYC to be congruent to angle YLA. Okay, I hope this was helpful, and I hope that you're able to get these notes down with no problem, and remember that the rest of this was proof, so we're not going to do that. So feel free to get those notes, please get those notes down. My in-person kids, this is a grade. And then you'll go and do your homework. For the virtual kids and for the in-person kids, we will practice in class. Thank you all so, so much.